We're going over AP Calculus AB/BC Unit 1 Limits and Continuity. This content is roughly 10 to 12% of the exam. So first off, Unit 1 covers evaluating limits, classifying limits, describing the ends, so using like infinite limits and limits at infinity to find asymptotes, and then finally applying theorems like the squeeze theorem and intermediate value theorem. Alright, first, what does a limit mean? So a limit just means when x gets arbitrarily close to c from both sides, and f of x also gets close to L. So for an example, it would be like limit of x squared plus 3 as x goes to 2. What is the answer of that? So you'd plug in 2 in for the limit and find the answer. So there's 3 ways you'll be asked. 1 is graphically, where you trace the curve. 2 is numerically. 3 is analytically. Alright. First is one-side limits and when a limit fails. So the limit exists when the limit on the left hand equals the limit on the right hand. If they disagree, the limit does not exist. And then there's 3 different types of discontinuities. You have a jump discontinuity, an unbounded discontinuity, and an oscillation, where it never settles on one value. And here are limit properties that you can always use. So first is sum and difference. So if you have a limit as x goes to x goes to c, and then another limit as x goes to c, you just add both of them together and you get your limit. Next one is quotient, where you split it up into 2 different things. Next one is power, where you just take the limit and then do it to like the power, whatever it's composed of, a square, a cube root, etc. Next is a product, where you just multiply 2 limits together. As you can see, they're pretty much all except composition. This is where you take the limit of the inside function and then just plug it back in. So that's the only one that's really different, but the rest of them are just your regular algebra. Alright, so step 1 is always substitution. So always try to do substitution. If you get a real number, it's done. So for example, if limit is x squared plus 1 as x goes to 2, the answer is just 5. Just plug in 2, and the answer you get is 5. However, if you get 0 over 0, which is indeterminate, you can do multiple things. You can factor, do conjugates, or simplify complex fractions. So the example we have here is limit as x goes to 2 of x squared minus 4 over x minus 2. So what we would do here is that we just factor x squared minus 4 into x plus 2 and x minus 2, and then we would cancel the 2x minus 2's, and then plug back in 2, which you get 2 plus 2 is 4. And finally, you get limit of a number over like a 1 over 0. So then you would have an infinite limit, and then you have some sort of vertical asymptote at c. Alright, for breaking the 0, 0 form, you would factor or cancel, multiply by conjugate, clear the complex fraction, or use a known trig limit. We'll be going over soon. Alright, so next is special trig limits. So first is limit as sine x over x is equal to 1. Next is limit as 1 minus cosine x over x is equal to 0. Make sure to memorize both of these because they definitely will show up in some problems and you definitely might get tricked on them. And then there's a special sort of example that they try to make you do, try to trip you up. So sine of 7x over x. So as you can see, this is not directly correlational to the limit that we have. So this limit is sine x over 7x, but our property says sine x over x. So what we would do is we'll multiply both sides by 7, multiply top and bottom by 7, so that we can simplify this limit to 1, and then we could do 7 times 1, which is just 7. Next is the squeeze theorem. So this says that if g of x is less than equal to f of x is less than equal to h of x near c, then the limit of g of x is equal to the limit of h of x is equal to L. So the limit of f of x is equal to L. And then a classic use is like x squared sine over 1 over x as x goes to 0, and then you bound it by 2 different sides, both of which equal 0, and then you just plug it in, and then you say that the last one is equal to 0 too. Alright, next is continuity at a point, and then so FC is defined. The point exists, no hole, no gap in the domain. The second one is limit as f of x exists. So the limit left-hand side and right-hand side limits have to agree and are finite. And finally, limit of f of x has to equal f of c. So this will determine if a function is continuous. So yeah, polynomials are continuous everywhere. Rationals, roots, logs, and tangent are continuous on their domains. Make sure to understand each one of these functions individually because they have different restrictions. And then to solve for a constant that makes a piecewise function continuous, set the left hand equal to the right hand limit at the breakpoint and then solve. So basically what this is saying is that if you have like a limit as x goes to 2 and then another limit as x goes to 2 of 2 different functions, try to put them together in order order to solve. And then next is the different types of discontinuities. So you have removable, jump, infinite. Yeah, pretty straightforward. All right, next is infinite limits. We already kind of went over this, but this is basically where they go to two separate values. So you have one going straight up to negative infinity. So the example that we have here is limit of 1 over x minus 3. So if you look at it from the negative side, it goes all the way up to negative infinity. If you look at it from the right-hand side, it goes all the way up to positive infinity because it will look something like this. It will look something like this, and then like that. Sorry, like this, and then so it'll be like a rational function. It'll be sloping downwards. Okay, next is limits at infinity and horizontal asymptotes. This is where we're trying to find out the different sort of degrees. So we have the degree of the top is greater than is less than the degree of the bottom, then y is equal to 0. If the degree of the top is equal to the degree of the bottom, then the ratio is the same, and then you just take the ratio. And finally, the degree of the top is a slant asymptote. Next is IVT, which this will be important, and this just says if f is continuous on A to B and k is any value between f of A and f of B, then there exists at least one value C in A to B with f of C equals k. And then how to write that justification, you'll say state that f is continuous on the closed interval, say y, the polynomial are given, compute f of A and f of B and show that k lies between them, conclude by saying by the IVT, there is a in between A and B where f of C equals k. And skipping the continuity sentence loses its point every single time, so make sure you do it. And here's an example. All right, here's some traps. I'm not going to read them, but just make sure to take note of these because they come up often. All right, here is a list of practice examples. I'll be sure to answer on the next slide, so please pause the video here and then go over them. All right, and here are the answers, so please make sure to double check. And yeah, here's a one-page recall, and thank you so much for watching.